Okay, so in the last video we ended by talking about x squared and sort of evaluating it around x equals 4. So that's where we'll start right now. We'll take some function, call it f of x, and it's x squared, right? And what we were talking about at the end of the last video is we said, all right, what is this function around 4? So we know it's about 16, right? So f of 4 is equal to 16. But what we don't want to do is we actually don't want to evaluate functions anymore. We just want to evaluate them around that point. So what we were saying was, okay, well, instead of evaluating f at exactly 4 and plugging in 4 here, what we'll do is we'll integrate it against some probability density function like this. In other words, take the expected value. So what we'd have is, so f of 4 is going to be ballpark close to negative infinity to infinity of f of x times p of x, which is the probability density function, dx, right? And so we said, this is probably going to be around 16, but let's prove it to ourselves. So let's do that in Desmos. And first thing is, let's say this is pretty similar to a Gaussian distribution. Okay, so let's go ahead and grab ourselves a Gaussian distribution, and we'll also get Desmos going. So the first thing we'll do is we'll just make f of x, and that's going to be what? That's x squared. Okay, and then the next thing we want to do is let's make a Gaussian. Okay, so Desmos Gaussian. Okay, and I think this one's nice. Perfect. Okay, so I'm just going to grab this little formula here, and I'm going to name that p of x is equal to here. Perfect. Okay, so now what are these sliders? I think b moves us around, so we want b to be centered at around 4. Okay, and then the next, a is our standard deviation, so let's move this to be about 0.1. I'm actually going to make it 0.05 just to make it pretty narrow and very simple, so everything is concentrated right around this 4. Okay, so now how do we do our evaluation? Well, what we do is we say, all right, we want to integrate. And what are our bounds of integration? Well, they're negative infinity to infinity. But this function here is essentially, well, let's find that out in a second. Let's just write the two functions we want to integrate. So f of x times p of x dx, okay? So now going back to these bounds of integration, well, f of x times p of x, that's going to be 0 pretty much everywhere other than right around 4. So I'm just going to be even over conservative and say, all right, negative 2 to about, positive 2, so this 2 to about that 6, and we'll see what we get here. Sure enough, we get 16.0025, which is right around this 16 that we wanted to find. So this is just saying that, if we take the expected value of x squared around 4 using this Gaussian distribution, we actually get around the value of x squared at 4. And so this is really nice because now if this function was like kind of poorly behaved and had discontinuities and weird things, what we could actually just do is just take the expected value given this probability density function, and we'd be pretty much good to go.